know about, man? What you know about, man? Hey, don't you know I represent, man? Me when I add shorty subtract, freshman backpack, where I'm holding all my work. And what you know about, man? What you know about, man? What you know about, man? I know all about, man.
Alright, guys. So here we are with 7.2. We're going to graph these rational functions, and so we're going to be looking at just about like 6 different graphs that we're doing on our extra practice. We're going to do a little bit of transformations as well, not so much like we did before, but a little bit. We're going to look at the domain and range again. So before we get into that, let's go ahead and just look at a quick Far Side cartoon. Got a dog in the corner. Looks like he's fooling the cat. Cat food. Alright, well, let's go on to look at our first core concept, which is the parent function for simple rational functions. So we have a simple rational function, which is just in this form, 1 over x, or really it could be like this, a over x, just a single number over the x. The x is in the denominator, and that's what really makes this a rational function, is that where the x is placed. It's always about where the x is. So when the x is in the denominator of a fraction, that means it's going to be a rational function. So this is not like just that an x is in a fraction. If the x is on the top, that does not mean it's a rational function. In fact, it would still be a linear function if x was on the top over a number. So what we can see here, it says the graph of the parent function, which would be 1 over x, is a hyperbola. Hyperbola is just the name of what this graph is. It looks like this here. It consists of 2 symmetrical parts called branches. So we call these 2 things the branches of our hyperbola. The domain and range are all non-zero real numbers. And so what we see here is we have 2 asymptotes. We have a vertical asymptote and a horizontal asymptote. We learned asymptotes when we were doing the in chapter 6 with exponentials and logarithms. We had to use asymptotes then. Well, a rational function is going to actually have both on the same graph. And so in this one, on the parent function, the x-axis and the y-axis are the actual asymptotes. So x equals 0, which is the y-axis here, y equals 0, which is the x-axis here, are those asymptotes. It says for any function in the form of this, where it's just got some number over x, and make sure that can't be 0 on the top, because then that would just make this whole thing 0. It has the same asymptotes, domain, and range as the function. In fact, if we think about what the domain and range of the function here is, the domain is all real numbers except 0, because it's going everywhere this way on this side, and it's also going everywhere this way. It's just not touching the y-axis. So it's just not touching 0. So really what we're going to say for our domain and range on these is just it's everywhere except where the asymptote is. So as long as we know what the asymptotes are, as far as like x equals 0 or y equals 0, we then can say what the domain and the range is. So the domain is the x equals 0, 1, everything, all real numbers except 0, and the range would also be the same thing, all real numbers except the 0, because our horizontal asymptote is the number 0. Alright, so let's go ahead and try a couple graphs now. Okay, so in exercises 1 and 2 on page 198, it says graph the function, compare the graph with the graph of our parent function, that's the 1 over x. So here's our a number. On top here, 0.25 is the a number, and over here it's -2. So what we got going on here is we're going to have to graph this, and I also want to graph the parent function. That's the best way to probably compare it. So I'm going to graph the parent function first, this 1 over x. And just like on our core concept, you can look at that core concept to see that graph again. But let's just go ahead and put it on here. We have to start it at 1, 1, and -1, -1. That's where all the parent function always is going to go through. So we start with just putting points right there. So go ahead and draw your coordinate plane on this, just right down the middle and across the middle. And just go 1, 1, and there's a point, and -1, -1, and there's another point. And from here, we're just going to draw the branches of our hyperbola. So 1 goes up towards the y-axis this way. Remember, these axes are going to be asymptotes. So we're just going to now go up towards the asymptote. So the 1 comes down this direction, and then it's got to go up the other direction there. And for the other branch, same thing. It's going to go towards the x-axis but not touch it. Get closer and closer to it, and then same thing for the y-axis, get closer down towards the y-axis. Just gets closer to those asymptotes, I should say, the x-axis and the y-axis, but they don't actually touch those asymptotes. They definitely can't cross it. So now we're going to go ahead and do a table of values, little t-chart, x and y t-chart, and we're going to put some numbers in for x. And the first number I'm thinking of is just 0.25, just what the numerator says. Because anything over itself, any number over itself, we should remember is just 1. So there's an ordered pair we can do. 0.25, if each box is worth 1 here like we were doing, 0.25 is like a quarter there and then 1 up. Let's go ahead and put that point then on our graph just right there. Next number I'm thinking of is 0.5. And 0.5 also could be like 0.50. So you could think of it as like this, 0.25 over 0.50, and so that's like 25 over 50, which is the same thing as saying 1/2. So that's just a 1/2 right there. So we can go ahead and plot that point. That's going to be right there in the middle of this box, half this way, half up. And the last one I'm thinking of is just putting 1 underneath. If I put something over 1, it's just going to be the numerator. So that would just give us that 0.25, which is a 1/4. As a fraction, so I changed it. These on the y-axis are fractions. So if I go over to 1, I'm going to go up to just a 1/4 or 0.25, and there it is. And let's go and continue to do it. We have to do some more numbers because we have to come over on this side. So this is what I chose here. I chose all positive numbers that went this direction on the x-axis, on the positive direction. Now I'm going to choose negative numbers for x to go this direction. And I'm going to choose exactly the same numbers except just negative this time. So -1. If I plug in -1, that's going to give us a -1/4. If I plug in negative, or there's my point there, -0.5, that's going to give me a -1/2. And I'll plot that point as well, right there in the middle of this box. And then the -0.25 is just going to give us -1. And let's plot that last one right there. So just like 1/4 over, a quarter over, and then all the way down 1. And now we're just going to draw the branches of the graph here, so it kind of gives us an idea. Here's where the kind of middle point is. We're going to go through this point and then get closer to the axes, and then do the same thing going up. So we just draw each one. So there's the lower branch, and then there's the upper branch. So you can kind of see right there the comparison between the parent function and the new function that we have is that this was actually just closer to the origin. So we can just kind of say that when it says compare the graph to the parent function, we can say, well, it's closer to the origin than f of x. G of x is closer to the origin than f of x. Okay, for number 2, we have a -2 on the top. So again, let's do this. Start off with the same way. Let's draw the parent function. So I'm going to put my points. First of all, draw your x-axis and y-axis right through the middle. Put a point here for 1, 1 and -1, 1. And let's go ahead and just, again, draw these hyperbolas. So with the branches stretching down towards our asymptotes, which are the x-axis and the y-axis. They'll just get closer and closer to them. So there's this one up on top, and here's this one on the bottom. So that's all you need to do to graph the parent function. You don't have to actually do any table of values. Just know 1, 1 and -1, 1 is where they start from, and then just go off of those points. But now with the 2, or the -2 on the top, let's go ahead and do a table of values for this. So we put a table of values. I'm going to pick some numbers, and again, be strategic about these numbers that we want to pick. So the first number I'm thinking of is the same as the numerator, -2. So anything over itself we know is going to be 1. So just -2, 1. Go ahead and plot that on our graph there. So -2 and up 1. Every box is worth 1. Next number I'm thinking of is -1. Now I'm keeping everything on this side right now at this point, going to the negative side of the y-axis on the x. And so -2 over -1, that's just going to give me a +2. Negative over negative is positive, and we plot that point. So -1, +2 puts me there. And then the third number I'm thinking of is -4, an even number. I wouldn't want to make a fraction. I want to try to get, or make 3 here or something else. 2 over 4 would be a half, and that would be a +1/2. So halves are easy to graph, and so I'll do the same thing there. So I'm going to come over 4 and then just go up half of the box. And then I'm going to do the same thing on this side. I'm going to pick the same exact numbers, just now positive form of them. So positive 2, that's going to give me a negative 1. So I'm going to go right 2 and down 1 for that one. And then positive 1, that's going to give me a negative 2. So I'm going to go right 1 and then down 2 for that point. And then positive 4, and that's going to give me a negative 1/2. So right 4 and then down 1/2 puts me right here. And then see our middle point between these 3 points. We want to go off of that one and then just go through that point and then get closer to the asymptote that we're going towards. And that's all you got to do to draw this. So there's our graph for this one as we draw the branches of the graph. So start from the middle point and stretch up. The middle point, stretch to the left. Over here, stretch to the right, stretch down. That's all it takes. And as far as comparing, as we can see here, we can see there's definitely a reflection happening. We got a negative up here for the number A. So there's definitely a reflection. It flipped over our axes here. So we got a reflection and it's further away from the origin. So we can see here. This one is closer to the origin. This one is further away as we look at where that middle point is. That's all we need to kind of say as we're comparing the graphs. Okay, now on the top of page 198, we see our next core concept that we want to talk about, which is graphing translations. Translations where we're shifting. We're shifting the graph left and right or shifting it up and down of just simple rational functions. So as you can see here, it's no longer just a over x. Now we have a binomial at the bottom, an x minus h. We also have a number out here, which is the k number. And remember, that's going to be your h is you're going to shift it left or right. The k will shift it up or down. And so what we want to do first, it says here step 1 is to draw the asymptotes. That's where the h and the k is going to be. So your asymptotes for the h, whatever the h number is, x equals h, that's your asymptote. Whatever the k is, y equals k, that's the asymptote. So the 1 for h is going to be the vertical asymptote going through where the x is. So if it says like x equals 2, then it's going to go through where 2 is on the x-axis vertically. And for this one, if this was a 2 for the k, then it's going to go through 2 right here horizontally. It's going to go through the 2 where the y is. So once we have those asymptotes, well, then we want to plot the points to the left and to the right of these asymptotes. So what I was doing before is going left and right of the origin, basically. Well, now I want to go left and right of this vertical asymptote. So I want to pick numbers on this side of this, kind of where the x is of the asymptote, and I also want to pick numbers on that side left of it as well. Kind of like I was just doing, but I was down here where the origin was. And then the last thing is just draw those branches just like we did. Alright, so let's go ahead and try a couple of these. Okay, so here on page 199, 3 and 4, it says graph the function, state the domain and range. So we're not going to bother graphing the parent function on these. We're just going to go ahead and graph just this as one. So the first thing to do is to find those asymptotes. Remember, we looked at those steps there on the core concept. You can see them there on your notes. And step number 1 is just identify what the asymptotes are. And so we're looking at h and k. So there's our h here. Remember, it's always opposite of what we think of. X minus 3, so that's going to be 3. K is going to be 5. So we're looking for our asymptotes first. And so this one, if we can think of this, is going to be x equaling the h. The h is 3, so it's going to be x equals 3, and it's going to be the y is going to equal the k, and the k is 5, so y equals 5. And so we want to plot our coordinate planes. So do this on your coordinate plane here. 2 boxes up, you can do your x-axis, and 3 boxes from the left, do your y-axis. That way we can get this on here properly. This is the window that we want to see. And we want to graph these lines first. I'm going to graph them just with a dashed line. So x equals 3. So we want to go over to where is x equal 3? 1, 2, 3. So it's got to be a vertical line. I'm going to make a dashed line going right through here where x equals 3. So you can see that's what I just did there with a vertical dashed line. And then we want to say where is y equal 5? So 1, 2, 3, 4, 5 is right up here. It's going to be a horizontal line going through where y equals 5, going straight across. And so we're going to put a dashed line also through that. So now we're looking for where is the middle of our asymptotes. Where does the x kind of become? And it's right here. That's the spot where we want to see as we start to understand what numbers we want to choose for x. We're going to choose numbers to the right of this, like 3 numbers to the right and then 3 numbers to the left of that spot to be able to get the 2 branches of this hyperbola. So we're going to look at a little table of values again, and so the numbers we're picking for x, I'm going to start on the right side. So this is at 3, so I'm going to pick 4. Just picking a number to plug in for x, and we'll just pick 4, and I'm going to pick 5 and 6 as well. So start off with 4, and we just think, okay, 4 minus 3. Well, that's just going to be 1. And 1 over 1 is 1, and then we have 1 plus 5. So that's going to be 6. If you need to do that on the side, go ahead and do that on the side. As you plug in the number, we plugged in 4, and then we saw that that's going to be 1 at the bottom. 1 over 1 is 1, and then plus the 5. I'm not going to do the extra little scratch work, but you can do that on the side if you want to. So I'm going to plot that point there. So there's 4, 6, and so that's in this quadrant here. We're in this, kind of the, if we think of this as 4 quadrants where this is, it's like the first one, Next number is 5, so now it's going to be 5 minus 3, that's going to be 2. So now it's a half plus 5, so that's going to just be 5 and a half. So if we come over to 5, we're going to go up to 5 and then a halfway up. We'll put a point there. So 5 and then 5 and a half. And then we'll do 6. 6 minus 3 is going to be 3, and so that's a 1/3. Now it's going to be 5 plus 1/3, which is 5 1/3. So we come over to 6, we go up to 5, which is where this asymptote is. We're going to go just 1/3 of the way up there, so it's a little bit lower. So it's right in that spot. And now let's go ahead and pick numbers on the left of this vertical asymptote. So I'm going to pick, starting with right here, number 2, and I can go 1, and I can go 0. I want to pick the same distance away, so I picked just 1, 2, 3 this way. I'm going to pick 1, 2, 3 that way. So I picked 2. Putting 2 here gives me a -1. That's going to give me -1 here. So when I take 1 away from 5, that's going to just be 4. So 2, 4. So I'm going to go to 2 and go up 4. We'll be right in that spot. And then the next number is going to be 1. 1 minus 3 is going to be a -2. And so that's a -1/2, which means we need to take half away from 5, which would be 4 1/2. And so we go to 1, we're going to go up to 4, and then halfway up. And so that's where our point would be. And then the last one is 0. So when I do put 0 in here, it's going to be -3. So now it's going to be a -1/3. So I got to take 1/3 away from 5. So actually that's going to be, if you think about how you take 1/3 away, remember there's always 3/3 in every whole number. So if you take 1/3 away, now you have 4 2/3 left. So 4 2/3 is left, and we'll go ahead and plot that point at 0, and right up here at 4 2/3 as it gets even closer to this asymptote, this horizontal one. So now that we have the 3 points on each side, we can go from this kind of middle point and then draw your branches. So I'm going to go from here down this way, and here to the left, going towards the asymptotes. I'm going to go from this middle one up towards this way, going through that point, and then this one to the right. So we have that branch right there drawn, and then this branch here. So that should look like that. And then as far as stating domain and range, they're very simple. Domain and range is always going to just be all real numbers except the numbers here, except these. And so for the x, it's except x equals 3, and for the range, it's going to be except y equals 5. So that's all it is here. So for domain, we'll just put a little d down here. Below it, all real numbers except 3, except that number 3. And then same thing for the range, all real numbers except 5 for the y, except 5. You could say except y equals 5, or you can just say except 5. And that's all you need. All right, so number 4. Now notice these have m of x, k of x. It doesn't matter. Remember the letters here don't matter. That's just function notation. So don't be worried about that. That just, again, means your y right there. So we're looking at this function. We're looking for h and k. Well, I don't see an h on this one. So that means our h would be 0 if we don't see it. And our k is right here at -4. So when we identify our asymptotes first, x is equal to 0. That's our h. And the y is equal to -4. That's the k number. And so that's what we got to do first. Go ahead and draw your coordinate plane here. We're kind of right through the middle with the y-axis, but 4 boxes down from the top, draw your x-axis. And we're going to now also draw in a dashed line, so use dashed lines to draw your asymptotes. Now, since x equals 0 actually is right on top, it's the vertical line right on top of our y-axis. Our y-axis really is our vertical asymptote on this one. So you can see I just put x equals 0. There's our asymptote. I kind of put a dashed line over it a little bit. But we just got to realize our y-axis is the asymptote on this one. And we got to go -4 on the y, so it's down 4. It's down to here. We're going to go across this -4 right here for the horizontal asymptote. And so we go ahead and draw that line. That's our y equals 4 line right across here. So now we want to see, okay, where do these asymptotes intersect? Where do they meet? They meet right here. And so we want to go to the right of this and pick 3 points this way. We want to go to the left of the y-axis and pick 3 points going this way. So we'll make a little table of values again. And we'll start with -3. So -3 puts me over here, -1, -2, -3. So I went to this direction. I'll probably come back towards this direction. And so I try to plug in -3 first. That is anything over itself equaling 1. So that would give us 1 minus 4, which actually is -3. So -3, -3 is a point. So we can go -3, -3 being a point there on that one. And then the next number I'm going to pick is -1. So -1 putting me right here. And so that's going to be plugging -1 inside here. That's going to be a +3. And so now we would have 3 minus 4, which is -1. So -1, -1 is also a point. That puts us right there at that coordinate, -1, -1. And then I'm picking -6. Now you might think, okay, well, why didn't I pick -2? I didn't pick -2 because that would give me -3 over -2, which would be an improper fraction there, and it might be a little more challenging to figure that out on the coordinate plane. So I'm choosing -6, and the reason why I'm choosing it, which is way over on the side here, so -6 is all the way to the end, is because when I put that here, 3 over 6 is a half. That's going to give me a +1/2 because they're negative over negative. So I'm going to get a +1/2 minus 4. So I take a half away from 4, that gives me a -3.5. So I put -3.5 for that one. So I'm going to come all the way over to -6 and then go down to -3.5. So it puts me, actually kind of down here. Yeah, there's -3. -3.5 puts me down to here. So the reason why I didn't choose this point is because it would put me, somewhere kind of in between here, and that's okay. You could have chosen that and had your points there. That would have been fine too. It would have had to be somewhere in the middle, somewhere in here. There's always more than one way you can do these. Okay, so on the right side, I'm going to pick some points. I'll just pick probably the opposite of these, not just positive numbers. So +3, it's going to give me a -1 and a -4, making -5. So 3, -5 puts me down here, right 3 down 5. And then +1. And so it's going to give me a -3 and a -4, making -7. So -1, -7, right 1 and down 7. And then +6. So I put +6 in here. It's going to give me a -1/2. So I'm going to actually add that and get -4.5 or -4.5. And so that puts me over here on the side, all the way over to 6, right 6, and then down 4.5. And now we're just ready to draw our graph. Go from the middle point that you have and then go up towards the asymptotes each direction. And so we have that branch right here on this side, and then we have the other branch going down on this side. So start from the middle one, just go off towards that point, then go off towards the other point. Middle one up towards the asymptote this way, so it kind of curves up, and this one's going to curve to the left. And as far as domain and range are going to go off our asymptotes, it's again all real numbers except for these numbers of the asymptote. So the domain is all real numbers except 0. That's what we would say for that one. And the range is all real numbers except this number, -4, because it just won't touch -4. All right, let's continue on for the next part. In fact, let's just take a little break here and just do a quick joke of the day. So our joke of the day here today is saying this. A mom texts, "Hi son, what does IDK, LY, and TTYL mean? He texts back, I don't know, love you, and talk to you later. The mom texts him, it's okay, don't worry about it, I'll ask your sister, love you too. She did not realize that he was actually answering what she asked. Okay, so on the bottom of page 197, I'm going to have to write some notes down. That blank space down the page, the bottom of 197. So go there, and I want you to write just like 3 things down, 3 parts down here. The first thing I'm going to have you do is write this down, this kind of big function here, y equals ax plus b over cx plus d. So when we have a rational function in that form, where basically you have kind of a binomial over a binomial, we have to do it a little bit differently. So we have, here's where we talk about the vertical asymptote and the horizontal asymptote. So the vertical asymptote, and here's what you write down, you could put a bullet point if you want to. The vertical asymptote of the graph is the line of that. So that's what you want to write there. So write all of that there for that one. And that's because, and you don't have to write this part though, because the function is undefined when the denominator is 0. The horizontal asymptote, you're going to write this part as well. So write that part there too. Horizontal asymptote is the line y equals a over c. So the vertical asymptote, the one that's going up and down, is going to be the opposite of d over c. The opposite of d over c, which actually is another way of saying this. If you took this denominator down here, cx plus d, if you did that, cx plus d, and you set that equal to 0, and you solved for x, you would get this. Because you would subtract d from both sides. Oops, it's a d. D from both sides, and now you get cx is equal to, because those would cancel, negative d, and then you just divide by c, and so now you get x is equal to negative d over c. So basically whatever you have at the bottom here, you can just set it equal to 0. That will give you your, and solve for x, that will give you your vertical asymptote. Your horizontal asymptote is going to be these numbers right here. So just these numbers right inside here, the a over the c number. So if they were both, if they just both started with x's there, they were both 1s, 1 over 1 would just be 1. But sometimes there might be numbers there, and you would have a over c is that asymptote. Alright, so let's go ahead and try a couple that are in this form now, and then we'll be done. Okay, so here we go with 5 and 6. It says, first of all, rewrite the function in the form g of x equals a over x minus h plus k. So he wants us to rewrite it instead of this form where it has the binomial over binomial. He wants us to put it back where we can see h and k. Then describe the graph of g as a transformation. What's it actually? Sorry, graph the function is the next thing. Graph the function. Then describe the graph of g as a transformation of the graph of kind of our parent function, sort of, with a over x. So first of all, let's go ahead and rewrite the function in this form. So to be able to do that, we have to go back and remember how to divide, divide polynomial expressions, because that's what we have here. Is we have a division with x plus 2 divided by x minus 5. And so we have to do long division with this. And so we're going to put our long division bar down. And the numerator, the top number goes underneath, or the top expression. So it's going to be x plus 2 underneath there. And then the bottom number, or the bottom part there, x minus 5, goes on the outside. And if you remember, this is what we do. We look at this first term x here, and we want to think, okay, what do I need to multiply this x by to get x here? Well, I don't really need to multiply by anything other than just 1. 1 times x will be x. So that's what I'm going to put up on top here, is just a 1. So 1 times x will give me the x that I need there. And then 1 times negative 5 will give me a negative 5 next to it right there. And then I'm going to go ahead and subtract this. As I subtract it, I'm going to be canceling out my x's. So I'm going to subtract this, meaning I have to change the signs of both the x and the 5. So the x becomes negative and the 5 becomes positive. So basically change both of these signs. That way these cancel out, the x's do, and now we have 2 plus 5, which is just 7. So now we can write the answer of this. Remember how we used to write the answer of this? Well, first of all, we're going to say g of x. We're going to use that instead of y. And we're going to write the, usually we did the quotient and then we said plus the remainder as a fraction. But this time we're going to put the remainder first next to our equal sign. We're going to write the remainder first, then plus the quotient. So we're just going to kind of do it a little bit backwards. So our remainder would be 7 on the top. So 7 over what we were dividing by, x minus 5. And then it's plus the quotient, so plus 1. And now it's in the form of where we can see h and k. We can see there's our h number, 5, and our k number is 1. So now we can go on to graphing it just like we did before. So we're going to graph this function. And like I said, we looked at that before with how do you find the asymptotes if you're in this form. If you just needed to find the asymptotes in this form and you didn't have to actually rewrite it or graph it, you can figure out the asymptotes. You're going to be saying x minus 5 and then equals 0. So you'd add 5. X equals 5 is going to be your vertical one. And then the numbers in front of your x's here, so they're both 1s. That over itself, so 1 over 1 is also 1. So let's look at our asymptotes here. So that was that, rewriting it. But now let's take a look at our asymptotes. We know the first one for x is going to be 5. Okay, it's right there. You can see the h number, or you can say x minus 5 equals 0, add 5, so x equals 5. The one for y, we could do this, a over c. And the a is up here. This is our c down here, so it's 1 over 1. And so we could just put that in, 1 over 1, which simplifies to 1. So y equals 1, which is the same thing as the k, though. So now that we have it in this form, we really just didn't need to do that. We could just look at this and say, well, there it is. Y equals k. So y equals 1 is that asymptote. All right, so the next thing to do then would be to draw our coordinate plane here. So do that. 4 boxes from the left, you're going to draw your y-axis, and looks like about 5 boxes from the bottom, draw your x-axis. And then we're going to use dashed lines to draw the asymptotes. So we got to go over to where x equals 5. So 1, 2, 3, 4, 5. So right through here is a vertical asymptote. So let's go ahead and put that one in. So a dashed line right through there. And then y equals 1. So we'll go up 1. And a horizontal line, a horizontal dashed line is going to be that asymptote. So we'll draw that one as well. And now we want to look, where do these asymptotes meet? They're meeting right here. So I want to pick numbers on this side. If this is 5, then I want to pick 6, 7, and 8. And then I want to pick numbers also on this side. And so that's what I'm going to do on my table of values. I'm going to just start picking numbers. So I'm going to pick 6, 7, and 8, just like I said. And then I also pick the 3 numbers on this side, which are going to be 4, 2, and 0. So I didn't pick exactly the same numbers. I didn't go 4, 3, 2. I actually skipped a little bit because I have more space over here. And that's fine. So as we now plug these numbers in, so I probably prefer to plug it into here instead of plugging x on top and on bottom. I could if I want to. I could put 6 up here, add 2, 6 down here, subtract 5. So that's an option too. Either way you could do this. So I'm going to plug 6 in, and I'm going to get basically 8 over 1. I actually could do it here, so that's going to give me 8 over 1, and that's probably the easier way maybe to do it. Instead of doing it down here, if I put it here, 6 is going to be 1, so 7 plus 1 is going to be 8. So yes, that does equal just 8 there. And so 6, 8, we can plot that point. So if I come over to 6, 8's actually just a little bit off the graph because I go up 1, 2, 3, 4, 5, 6, 7, and 8's just 1 off the graph. I plug in 7, I'm going to get 9 over 2. So I'm just doing it up here. 7 plus 2, 7 minus 5. 9 over 2. 9 over 2 is 4.5. So when I come over to 7, I'm going to go up 4.5, and I can plot that point. When I plug in 8, I'm going to get 10 over 3. So 8 plus 2 and 8 minus 5 is 10 over 3. And I could divide that. 10 divided by 3 is going to be 3.3. It's actually going to be repeating. It's really 3 1/3 as a fraction. So when I go over to 8 all the way to the side over here, 1, 2, 3, and then a third up, we're right about in there. Just do your best at estimating where to put that point. But it should be definitely above 3 right there. And then when I go to 4, I have 4 plus 2, 4 minus 5, so it's 6 over negative 1, which is just a negative 6. And so we're going to come to 4 and go down 6. That's just 1 off the graph this way. And I put 2 in. 2 plus 2 and 2 minus 5. So it's going to be a 4 over negative 3, which is the same thing as saying a negative 1.3. So negative 1.3. So when I come to 2, I'm going to go down negative 1 and then just a little bit under that. And I'll be putting it there. When I plug in 0, 0 plus 2, 0 minus 5, it's going to be just 2 over negative 5. And so when I go to 0, I'm going to go down just a little bit, not too far. So kind of estimate right in there and put a point. Now you just got to draw your branches. So go ahead and draw the branches like we've done before. And the last thing it says now is describe the graph as a transformation of the graph of a over x. So our a in this case is 7. So how is it different from 7 over x? Well, because it changed with the h and the k. So it did a translation. It moved, it shifted, because we have 5 here. It shifted right 5 and up 1, basically. You can kind of see where the origin was. That's where it would be if it was just a over x, because the asymptotes would be the x and the y-axis. But now what changed was it actually just shifted right 5 and up 1. So that's what we can say. Translate 5 units right and 1 unit up from this graph of 7 over x. Alright, our last one here, number 6. So the first thing we're going to do is change the form here. So we got to do our division like we did before. So long division, the numerator goes underneath and the denominator goes on the outside. And we got to figure out now, what do I need to multiply 3x by to get a 2x? Well, that's going to be a little more difficult because there's nothing you can think of that can multiply it as a whole number, so it's going to have to be a fraction. You need it to stay 2, but you need to be able to get rid of 3, so I would multiply by 2/3. Because if you multiply by 2/3, you can cross cancel the 3's, and now you just have a 2. And so you can see it, my little scratch work over here. If I did 3 times 2/3, I'm crossing out the 3's here, and that would just equal 2. And so now that would give me 2x right there. So that's how I can get that 2x to go there. And now I got to do 2/3 times a negative 12 to figure out what to put underneath this positive 8. So I'm going to do 12 times the 2/3, and I can cross cancel 3 and 12. 3 goes into 12 4 times. So now it's just 4 times 2, which is 8. So we have a negative, though. 2/3 times a negative is going to actually be a negative 8 going underneath there. So minus 8, 2x minus 8. And now we have to subtract, which means change the signs of both of these. This will become negative 2x, positive 8, like that, and we'll subtract them. And so 8 plus 8 would give us 16 for a remainder. And so as we write this now, we're going to start with g of x. And our remainder is going to go first. So 16 is the numerator. And then what we were dividing by is 3x minus 12. And then our quotient, the 2/3, is going to be at the end. We're going to say plus 2/3 at the end. And so there's our rewritten function in that form. And here we can just go off of the h and the k as well, or we can think of it as, we know that we can, to find the h, we're going to have to solve this anyways. So starting with asymptotes here, I'm going to do this one in a green color. So to find the asymptotes, I'm going to have to take 3x minus 12 and set it equal to 0, like I'm doing over here, and solve for x so I could figure out what the h is. So I'm going to just do that, add 12 to both sides, and then divide by 3, x equals 4. So there's my asymptote for the vertical one. So h would be 4, so x equals 4 is what that would be. Because your h is not 12. It's not going to be 12 because we do have a 3 in front of here. And then as far as what the other asymptote is going to be for y, you can see it right here. It's just the 2/3, or you can even see it right here. It's this number over this number, the a over the c, which is just 2 over 3 here as well. So 2/3 is the other asymptote. So we're going to plot where 4 is. So come 4 to the right. You're going to go through there. Actually, go ahead and draw your coordinate plane, I should say. So 4 from the left, draw your y-axis. Right through the middle here, you're going to draw the x-axis. And we're also going to draw the asymptotes now, dashed lines going through 4. So come over to 4 this way, and you're going to draw your dashed line going up and down. and then 2/3. So you got to go up 2/3, so not quite to 1. So up 2/3, more than half though, and then draw another dashed line going through there. Just do your best at estimating that. And now we're going to do our little table of values and picking some points. We need to see where is our middle here. Here's the middle. So which is really the vertical asymptote here is at 4. So I want to pick numbers on this side like 5, 6, 7, and so on. Pick numbers on this side like 3, 2, 1, or 0. And so the numbers I'm going to pick 5, 6, and 7 on the right side of this, a vertical asymptote, and I'm going to pick 3, 2, and 1 on the left side. And so we'll just start plugging these numbers in, and we could do it either up here or in here, and it doesn't matter. It'd probably be easier to do it up here, I think, actually. So when I plug 5 in, it's going to be 2 times 5. That's going to be 10 plus 8 on the top, which will give me an 18. 3 times 5 is 15. 15 minus 12 on the bottom, which is 3. So 18 over 3 is actually 6. So 5 comma 6. So we're going to go right 5 and up 6, puts us all the way up here. When I plug in 6, 2 times 6 is 12, so 12 plus 8 on the top, and then 3 times 6 is 18, 18 minus 12 on the bottom. So that's going to give me 20 over 6. 20 over 6, when I simplify that, is a 10/3, which actually we did 10/3 over here on this side, and it's 3.3, or 3 1/3. So that's what we want to do. It's going to go to 6, and then up 3 1/3. So that puts us right about in here. Come over to 6, there's 3, and then up 1/3. And then the next number 7, so that's going to be 14 plus 8, 21 minus 12. And so it's going to give us 22 over 9 when we do that. So just plugging the numbers in, figuring out what the numerator is going to be, the denominator is going to be. And 22 over 9, that would be 2.4 if I divided that. 22 divided by 9 is around 2.4. So go over to 7 and go up to 2, and 2.4 is a little bit under a half. When I plug in 3, we're going to get 6 plus 8 and 9 minus 12. That's going to give us 14 over negative 3. And if I work that one out, I can make that improper fraction into a mixed number, and it can be negative, or yeah, it's going to be negative 4 and 2/3 then as well, because 3 goes into 14 4 times with 2 left over. And so when we go to 3, right 3 and down 4 and 2/3, right 3 and then down 4 and then 2/3 more, puts us down there. And then when I plug in 2, it's going to be 4 plus 8, 6 minus 12. So it's going to be 12 over negative 6, which is actually just a negative 2. So 2, negative 2, right 2, down 2. When I plug in 1, it's going to be 2 plus 8 and 3 minus 12. So it's going to be 10 over negative 9. So that's just going to be a little bit more than 1. So I can say, well, 9 goes into 10 one time. So if you're going to go to 1 here, you're going to go negative direction, down 1, and just a little bit underneath 1, because there's only 1 left over. So we can put that point right underneath here. And now we just draw our branches like we've done before. Let's go ahead and draw each branch. And now we're ready to do this last part here, which is just describing the transformation. So again, that's going off of really where, what's going on with these asymptotes, this transformation, where it went from this point at the origin to this point over here. It moved, it translated 4 units right, and then 2/3 up, 2/3 of a unit up. And so that's what we can say, translate 4 units right and 2/3 up from f of x equals 16 over x, because 16 is our a number, because remember it's talking about a over x here. So we just use our top number, 16 over x, that's what it would be. So if it was just a 16 over x, it would be pretty much the same thing, just back over here at the origin, and it would be the same kind of graph there. Alright, so I know that took a little bit of time, but that concludes this lesson for 7.2. So you want to work on your assignment now for 7.2, and I'll see you back in class.